Hello and welcome to the LUniverse Virtual Planetarium from Lancaster University. The following is a recording of one of our free live public shows that we ran during early 2021. I hope you enjoy.
With all that out the way, today we're going to try a little something a bit more impromptu than I usually do, which probably means it's not going to work, but I'm going to give it a go anyway. So I'm going to bring up our standard planetarium here. I say standard, I always think it's quite cool. And we will have a little look at what you will see this evening. So this is what our night sky will look at 12 o'clock. Nope, sorry, 10 o'clock, 10:30 to be precise, this evening, including some of the effects of light pollution that you get here in Lancaster. And now we're going to be questioning, so what are we able to see this evening? Well, this is a show about the constellations, so let's see what constellations will be visible. So the easiest one to start with is if we go over to the southwest. If you go southwest and look directly upwards, you should then be able to see a collection of 3 stars right there. Nice and easy to spot. Those 3 stars make up the belt of Orion, known quite simply as Orion's belt. Super easy to spot all year round, well worth the at this time of year. It's not all year round, it's just this time of year, but very easy to spot at the moment, nice and clear, high from the sky and away from the equator, so the horizon. So nice and easy to spot 3 stars there. If we then move our way over to the north, between the north and northwest, and we have a look upwards, you should then be able to spot the stars here, these stars in a collection here, that make up the W, and that W forms Cassiopeia. So again, that is northwest. You look up, you should be able to see the 5 stars that make up the Cassiopeia W. Pretty cool. If we continue looking towards the northeast, so northeast, and then look up, you should be able to spot quite clearly right in the center-ish there, center top, probably the easiest to spot and definitely the most famous of all the constellations. It is, of course, Ursa Major, easily identifiable by the plough, the Big Dipper, the saucepan, the frying pan, the pot with a handle, the various names for it. But that is right there. You've got the 3 stars here that make up the handle and the 4 stars here that make up the pot, which of course is the tail and the bum of the Great Bear of Ursa Major. You also have Ursa Minor to the side as the little one. Fun fact, if you're on the team that was here last week and we spoke about my favorite of all the stupid constellations, which is here, if you manage to find Ursa Major tonight, again by looking up from the northeast, straight up, the 3 stars that form there. If you then go across and you see the 2 stars here, that gets us Canis Venatici, I really don't know, and that forms those 2 dogs that somehow are depicted by those 2 stars there. Great one to spot if you found Ursa Major, nice and easy. Another one that is potentially visible tonight a bit later on. So if we increase time here a little bit, we can go a bit later in the night around the northeast and east area. We also have Hercules, straight above the horizon. It might be a little bit hard to see because things on the horizon have a lot of light pollution. They also have refractions and reflections from the sun, which make them a lot harder to see. But yeah, northeast, east, if you look up, you should also be able to see Hercules. Pretty cool. So those are just some of the constellations that are easily identifiable tonight. They're definitely some of the easiest to spot. Ursa Major, Orion, Cassiopeia are definitely some of the brightest in the sky, visible for most parts of the evening as well, because of course for how high they are. So they're definitely worth going to have a look at tonight. The weather in Lancaster today has been unbelievably bright and sunny, which is just not how this country is meant to work, especially not this part. So do go out and have a little look with a nice safe adult if you can do so. Right, with all of that out the way of that little quick refresher of what the constellations are and some of the ones that you can view this evening, I will hand over to George and Pascal, who will be doing the Q&A for us today. We'll start off with George, who will introduce himself, and then Pascal will start asking lots of lovely questions. Over to you, George.
Well, thanks for that lovely introduction, Andrew. My name is George. I am a PhD student at Lancaster University, and I am lucky to work with my favorite planet, which is Saturn. And basically, I'm working with a specific instrument on the Cassini spacecraft. The Cassini spacecraft was a spacecraft that was orbiting Saturn for 14 years and got lots and lots and lots of data. And we're super happy for that because right now we have a lot of data to analyze. But also, I have also the luck to be born in Greece, where a lot of the constellations, as we know, as the world knows them today, got their names off, and the mythology and the tales basically originated from Greece. And also, we have the luck, because we're closer to the equator, to see more stars, as in a bigger part of the sky. So yeah, that's who I am, and that's my passion. That's astronomy for me.
So thanks for that. The first question that we have is, what is the most remarkable story about constellations that you've heard of?
Oh, that's an interesting question. I mean, if you like stories, then go grab a book about the Greek mythology or any other mythology, about the constellations, and just dive into it. You will get excited, and your mind will be blown with the things that the human mind can connect. As in, you're seeing the dots up there, and you're seeing a bear, where basically you're seeing 7 stars, 7 dots. Now, the most remarkable constellation story that I know about, I would say that it's I would say it's the Big Dipper and the Small Dipper, or the Big Bear and the Small Bear, because it's a bit different. We see, here in Greece, we see the constellation a bit differently than you see it in the UK. But long story short, the story goes like this. Once upon a time, there was Callisto, which was, if I'm not mistaken, queen of a kingdom in Greece, and Zeus fell in love with her. Her and Zeus had Arcadas, a boy named Arcadas, and when Hera, which was Zeus' wife, learned about that, she got so mad that she transformed Callisto into a bear. And as a bear, she was sentenced, let's say, to live in the forest, and she chose to live in a nearby forest of her palace. And while Arcas was growing up, he started learning hunting. And at some point, one day he goes hunting and he sees a bear. He sees basically his mother. Callisto is getting so excited that she sees her son after so many years that she rushes towards him to hug him. But if you see a bear coming towards your place, the last thing that you're expecting is a hug. So Arcas is trying to defend himself, and he's trying to kill the bear. Basically, he's trying to kill his mother. Zeus sees the whole thing, and he puts them on the very last moment up in the sky as constellations, so they could live through eternity together. But Hera, here's the different part, that the interesting part that I told you about. Hera was still pissed about the whole situation. Now, basic astronomy, the whole sky rotates during the night. So you have constellations that are setting and rising. The ancient Greeks believed that when a constellation was going into the water, was setting into the water, that constellation was getting some rest, was going, going to sleep somehow. And when the constellation was rising, it was basically the beginning of a new day. So back to our story. Ira was so angry with the whole situation that cursed both of them to never set, to stay up in the night sky for throughout the eternity. And I think that's the point where I find more fascinating, the fact that they show, the mythology shows that gods also have human, let's say, defects. They have human feelings. They can feel love, they can feel anger. And that's what excites me.
Thanks for that, George. So the next question that we've had through is, how much mass does a black hole have?
Ooh, really, really interesting question. So I would say with the phrase a lot. What I mean by that, if you have a star, you need the core of the star to be over, if I'm not mistaken, 3.2 solar masses in order for that star to become a black hole. And a bit short on how a black hole is created. Basically, you have a star. The star is running fuel in order to keep burning, and at some point, the fuels are running out. Why is that important? The fuel that burns basically have a pressure outside the star. If you say that this is, let's say, if that's the surface of the star and that's the core of the star, then there is a pressure outside that pushes the star, but also there is gravity that pushes everything towards the center. Those two pressures are the same in order for the star to be stable. Now, back to the core and the fuel. Now, when the fuel runs out, basically you don't have that pressure that pushes outside, so you only have gravity. And gravity, I will not go into too much detail on that. Gravity just pushes everything, and the core of the star is getting really, really, really shrunk. And if it's over 3.2 masses, that core, then it becomes a black hole. I know that I think that the latest thing that I've seen about black hole, about weight of the black holes, I think that the heaviest black hole is about 10 billion solar masses, which is an insane number. And I'm not sure if that has changed or not. I mean, that's an easy thing for you to look at.
So continuing on the black hole theme for a moment, what would happen if a black hole collided with another black hole?
Ooh, exciting and fun things. Well, if we observe it and becomes like really, really, really far, we will be able, most probably, to detect gravitational waves. But that's from our perspective. Now, if two black holes collide, I'm not really sure on what will happen, on what will physically happen. I don't know if there's going to be like a huge explosion or if it's just going to be something that we cannot see due to the nature of the black holes, that all the information, everything will happen inside the black hole. But one thing is for sure, a black hole is not as black as we think it is. We have the core of the black hole in the center that, of course, nothing escapes, not even the light, but around the black hole, there's a whole system that just emits light. And why is that? You have a solid object in the universe. that solid object, most probably it's going to spin. And if an object spins, then you have gas gathering around the black hole. That gas is being heated and it starts radiating. So while you cannot see the black hole and while nothing from the black hole can escape, you can identify and you can observe that bright glowing gas. So if you have two black holes rotating, and at some point, boom, then I'm expecting to have something really, really, really bright that we will be able to observe that it will be able to be observed for many astronomical units or parsecs.
Thank you. So going back to constellations now, are there any constellations that you know of that have two different stories associated with them?
So I'm not sure if I said that, if I mentioned that, but every civilization has different mythology, or they see, every civilization sees different things up there. The ancient Greeks, as I said, are seeing what we know as Orion and Perseus and Cassiopeia and so on. But for example, I think the indigenous Americans are seeing what we know as the Big Dipper. They know it as the Seven Brothers, if I'm not mistaken, and of course the story is quite different than ours. So if you go cross, how can I say that? If you go in between, cultures, then you will see that everything changes. Almost everything changes. But also in the same culture, for example, if you only focus on the Greek mythology, due to the fact that we don't have writing scripts, and in the beginning was only word of mouth, then you will have different stories for the same constellation. I know that Scorpion and Orion have a couple of different variants, but I'm not sure. Sorry, I don't remember the different versions of that.
Thanks. So next up, why are some constellations so small, such as the Triangle?
That's an excellent question. I'm gonna ask for that question, you guys, you, the viewers, to play a game. Go outside on a clean night. I know it's a bit hard in the UK to find like a cloudless night, but go outside and forget everything you know about constellations and start making your own constellations. Where am I getting with that? It's all about the imagination of the people who created the constellations. So I would say that it's purely, out of luck that some constellations are smaller than others. Also, that's combined with how bright the stars are. For example, if you see Orion, you see 3, 2, and 2 stars just popping out. That it's normal, somehow, goes natural for you to categorize those stars, and you say, oh, that's a constellation. But if the stars are a bit dimmer, then you start breaking the stars into a different way, let's say. So I would say that it's purely out of luck that some constellations got, a bigger space in space.
So that links quite nicely to our next question, which is, with the constellations we can see with our eyes, what distance are they from Earth?
That's an excellent question. And my answer to that is, let's think about it. all the constellations that we're seeing in the night sky are made of stars. All the stars are stars that belong in our own galaxy. So you can put an upper limit over there that, since you know that our galaxy is about 200,000 200,000 light years across, since we're assumed that our galaxy is a spiral one, so you assume that you have like a disk. So the diameter of that disk is 200,000 light years across. So you know that all the stars are within that distance. Now, that varies, because if you have a really, really, really dim star, I'm sorry, it doesn't, the distance is the same. The question about, the distance of the stars varies. If you have a star that's really, really, really dim, and that's right next to you, and you have a huge star that's a bit farther, then in your eyes, that huge star will still be brighter. So it all depends on how bright the stars are and what's their distance on you being able to see that. But I don't have a straight answer on what is the furthest star that we can see, but I can put an upper limit on that.
Next up, why do constellations have stories behind them in the first place?
I'll take you back. Imagine that you don't have internet. Imagine that you don't have anything, no books, no internet, no nothing. And also, most important, no electricity. So no lights during the night. You want something and you start appreciating and you start wondering about your surroundings and about, the earth that you're standing on and about the sky that you're looking at. So it's only, in my opinion, it's only natural for you to start connecting the dots, literally. You see those stars up there, and then your imagination, starts running wild, as in, oh, that could be a bear, a bigger bear, and oh, that looks like that thing that I called Big Bear, but it's slightly smaller. So I would say that this is the small bear. And oh, look, between the two bears, there is like a line, and that line could be a huge dragon. So how does those things, just went up in the sky? And that way you start creating your own story. You start creating story, mostly to amuse yourself, but also to try to explain what you're seeing up there.
Thanks. So next up, going into your area of expertise, did Saturn's moons all form at the same time?
That's an excellent question. I don't know it on top of my head, but I would say no. And why is that? We can see a lot of moons. Basically, Saturn has or a planet, a giant planet that has a lot of moons. You have moons that are how it's called? The two orbits. It's the orbit that follows the rotation of the planet and the orbit that goes against the rotation of the planet. So a planet orbit spins. That's one thing for sure. So all the objects tend to spin with the planet. So all the objects that are basically the moons tend to be on the same plane, on the same level, let's say. But for example, on Saturn, you see moons that don't follow that rotation and they don't go on that plane. You see moons that are a bit off and they're going counterclockwise or against that rotation. So that I think can tell us that not all moons create on the same time. Also, another thing that you can have in your mind is that you are you have a system with you have a lot of bodies orbiting around the sun. So around the planet, around Saturn. Inevitably, some of those bodies will crash to each other. That's how you get new moons of Saturn. So, yeah, I think that's covered.
Staying on Saturn for a moment, why does Saturn have rings? How did they form? And are they drifting apart or getting closer together?
That's another excellent question. I don't really know the answer on how the moons got there, but I think the moons can be considered to be a failed, let's say, moon, as in a moon that couldn't, just become a solid, and so it broke down and created that beautiful system of the rings. Now about drifting away or falling into Saturn. I'm not really sure about that. I would. I've heard somewhere that basically, if I take Earth for example, we have all the satellites that are orbiting Earth. I've heard that basically I read somewhere that if all satellites just, if we lose all communication with the satellites, eventually those satellites will fall onto Earth. So, but with the moon is the exact opposite situation. The moon drifts away from the Earth. So there should be a limit around Saturn that all the bodies inside that limit will fall onto the Saturn, and all the bodies outside of that limit will just drift away. The thing is, I don't know where that limit is. And now that we're at the moons, an awesome part that I learned that the moons, I know that that's not a question, but I want to share that. So the moons are mainly consisted by ice, by frozen water. The awesome part about the moons is their thickness. Saturn is about 10 times, the diameter of Saturn is about 10 times the diameter of the Earth. We're talking right now about around 60,000 kilometers. That's the radius. So the diameter is 120,000 kilometers. That's, if I'm not mistaken, almost halfway from the Earth to the moon. Maybe not. Maybe I'm. Anyway, that's a big distance. Now the thickness of the rings is insanely small. Their thickness is maximum 1 kilometer, and you're asking why can't we see them, that clearly? And the answer is because they're made of ice, and ice reflects almost all the sunlight that hits on it. And yeah, I'm done here.
So next up, have all the stars in our galaxy been discovered?
Absolutely not. And why am I saying that? Well, what you see, so if you go out in the nature, or if you find a perfect night that it's not cloudy and there is also no moon, on the night sky, you will basically see a stripe of stars. That's our galaxy. I'm pretty sure that if you like astronomy, you've heard that before. But the thing is, our galaxy is a spiral galaxy, but we see the edge of it. So basically, if we say that this is our galaxy, I don't have anything else that could be more convenient. But yes, imagine that this is our galaxy. The Earth is somewhere here. So basically, what you're seeing is that edge. That's the white stripe of stars. Now, why am I saying that not all the stars have been discovered? Let's flip that. What you see is basically that part of stars over here. You have no idea what's going on over here. And there are millions and millions of stars that haven't been discovered yet.
So going back to planets now, is there a solid core inside the gas planets?
Yes, there is. So, and how we know that? We know that the gas giants have magnetic fields. And a way that you can create a magnetic field is basically taking a solid or taking something solid that contains a lot of metal and start spinning it. That's what's going on Saturn. Now, the thing is that when the whole system, when the whole solar system was being created, you can see a pattern, as in you have the sun burning bright, and the first planets that you see is they are full of rocks. They're rocky planets, and after that you have the gas giants, the gassy planets. So you have that solid core, but because of the gravity, that solid core started bringing gas from all around the place, and that's why you can see a gas giant. But yes, there is a core on all the gas giant planets.
Are there more rings around Saturn that we can't see?
That's an excellent question. Yes, there are. If you take a telescope, basically you can see the basic rings. The A, B, C, D, and E, if I'm not mistaken. There is an E as well. Now, close to the last. Okay, let me take that question through another way. If you see with a telescope, that means that you're seeing on the visible spectrum. Now, since we're that far, we cannot see another tiny ring that's really close to the last ring. I think it's ring A. That's the ring F. Cassini managed to get a couple of pictures of it, so we know that it exists. I'm not sure if there is another ring further outside F, but there is, I think, the so-called Phoebe ring. I'm not okay. Here is the part where I'm not sure. I know that there are more rings, but they're visible on the infrared spectrum. That means that you're using a different wavelength to detect them because their properties are different. And I remember that one of them is like in an insane distance from Saturn, as in millions and millions of kilometers away. I'm not really sure which one it is. I'm not sure if it's the Phoebe one, the so-called Phoebe one, but yes, there are more rings, and I'm sorry that I don't remember. It's a fun thing to look at, huh?
Thanks. So next, if there are so many stars in the sky, why is the sky black?
Can I ask can I ask that question to? Okay, I assume that I'm the expert. So that's an excellent question. Let's think about it a bit, and if our train of thoughts is wrong, then let's review it in one of our next sessions. So let's take the example of Earth. Why isn't the sky black? The Earth has an atmosphere, and where does that help? If you have the sun, if you have a bright source, then you have the sun rays falling onto the atmosphere and being scattered all around the place. So you have sun rays almost everywhere. What's going on now during the night? You have the atmosphere, of course, again. If you ever use a telescope to observe a star, then you will see that sometimes the idol that you're getting is not sharp. So what does that mean? It's like a bit blurry. That means that the atmosphere is also contributing on the stars, not to be like points. It diffuses, let's say, the light. I would say that from the Earth, the sky is black because the stars don't have enough light to go around, to brighten up our entire atmosphere. And you can see that you can see that opposition with having the sun during the daytime, and the stars during the nighttime. But also, let me get in Andrew's words. The best solutions at present is that the universe is not infinitely old. It's really old, but it's not infinitely old. That means that we can only see objects as far as the distance light can travel on the age of the universe. The lights from all the stars that are farther that distance basically didn't have the chance to reach us yet. And that doesn't, contribute on making the sky brighter. And another reason is that the sky may not be bright with the visible light of all the stars is because light source might be moving away from you. So you get less light, or you get the light to be shifted towards the red spectrum. That's a really complicated question, though.
Okay, thanks for that answer. So I think this is the last question now, and we'll end with, is Saturn hot or cold?
My question will be where? Surface, position of the star, depth. I would say Saturn is quite far from the sun, so not that much sunlight goes there, and also it doesn't have it doesn't show any effects of let's say greenhouse effect like Venus has. So I would say that it's primarily cold.
But I must now take the opportunity to say a massive thank you to George, who beautifully answered those questions. Give us a little wave, George.
Thank you
so much for your time. Absolutely brilliant. And a thank you as well to Pascal, who managed everything behind the scenes. Absolutely fantastic. Thank you ever so much, Pascal.
Thank you for watching, and I hope you enjoyed learning a little more about our amazing universe. Our team from Lancaster University also runs shows for schools, community groups and more, both in person with our portable inflatable planetarium and online. But any in-person events are subject to current COVID restrictions. If you're a teacher, community group leader or part of a similar educational organisation, please do get in touch. We're particularly keen to make connections with those in our region of Lancashire and Cumbria, but we'd love to hear from you wherever you are. But for now, take care and keep learning more about the amazing wonders of our night sky. Thank you.